positive of it. Okay, so now here's what's going to happen. The rest of the time is going to be taking a look at e to the x and natural log of x. So the first thing I want you to do is I do want you to graph these two things right here. So I want you to pull out your graphing calculators, and then I want you to graph them and go through and then sketch the graph over here and then tell me what you notice. So go ahead, stop your video right now, and then graph this, and then try to think about how to, sketch the graph of the other one. So here we go. Let's take a look at what this looks like. So first of all, you do need to note that e to the x is a graph that looks like this. Remember, this is an exponential function. Okay? And all exponential functions have the same properties. One of them is that they all go through number 1, okay, on the y-axis, because anything to the 0 power is 1. And then it just grows really, really fast once you get into the positives. Now, here's the thing. I want you to think about, first of all, how could we draw the graph of this without using our calculators or anything else? So remember, when I said looking at graphs before, you need to just pick like some random spots, and you just kind of need to figure out what's going on with the slope, okay? So if I look here and I draw the tangent line, notice the slope is really low. So on my new graph, at the same spot, I'm going to have a really small slope. So I'm going to put my first dot there. Now notice when I go like this at my next dot, notice that it starts getting a little bit steeper. So when I go to that spot here, I'm going to make it a little bit higher than the other one, okay? And then notice as I draw my tangent line at 0, okay? Oops, I put it in the wrong spot, so let's move it right there. If I go to 0, it's getting a little steeper yet, okay? And then notice it's getting steeper and steeper. So it just starts going up and up. So here's the weird thing about e to the x. The derivative of e to the x is actually e to the x, okay? So when you look down here, the derivative of e to the x, I want you to write e to the x, okay? They are equal. Now, I do want to review with you how to do this on your graphing calculator as well. So let's just go into our graphing calculator. Nope, it's the wrong one. And let's clear this out, and let's just put e to the x. Let's do second e to the x. And then let's zoom it into a standard window, and you should see the graph just kind of go like that. There's your basic graph. Now, what if I want you to graph the derivative? So I want you to remember what we did the other day. So if you remember in math, under it's in, nope, let me do this again. In math, and we go down a little bit, yes, under math number 8, you'll see n deriv. So that's the one we want. And then what we're going to do is we're going to do second e to the x. But remember, we're going to put what variable we want it to work with. So we're going to put x. And then what number do we want it to look at? Well, we want to look at all numbers. So we're going to do comma x, because what that's going to do is that's going to check every x. And then we are going to graph it. But I am going to turn off the first one, so we only see the second graph. And then we're going to graph it. And then let the calculator do its thing. And you notice, look what's happening. It's graphing the exact same thing that you saw before. Okay? So the thing you need to know is the derivative of e to the x is itself. So how are we going to use that? So let's go through, and I'm going to show you several problems that involve using e to the x. Okay? So first one, let's find the derivative of this. And I'm just going to kind of work my way through and just note that there's a couple of things. So this is using e to the x with the chain rule. So the first thing you need to note is your inside function and then your outside function. So your inside function is 2x minus 1. Your outside function is e to the x. So take the derivative of each one. So we just learned the derivative of e to the x is e to the x. And then, of course, the derivative of this is 2. So if you remember everything that we've been doing, you take this and you substitute that in. So it's going to be e to the 2x minus 1 times, move across, the derivative of that. So here is our derivative. So dy dx equals this function. Okay? That's how we use the chain rule and e to the x. So now, let's take a look at this next one. E to the 3 over x. Okay? So we have e to the 3 over x. So let's think about how we're going to do this. This, again, is the chain rule. So you need to look. This exponent is your inside function. So my inside is 3 over x. Okay? My outside, again, is e to the x. So let's review what we do. So we take the derivative of the outside, which is going to be e to the x. And now this one, it's not nice working with 3 over x. So what we're going to do is we're going to change this to 3 to the x minus 1. Okay? And now we're going to take the derivative of that. So that's going to be negative 3 x to the minus 2, or negative 3 over x squared. Okay? So let's go through and use the chain rule. So we're still going to do this and substitute this in. So it's going to be e to the 3 over x. But then I have to multiply it by the next part in the chain, which is going to be negative 3 over x squared. So when we multiply all that together, it's going to equal negative 3 e to the 3 over x all over x squared. And there is going to be your derivative of this function. Okay? So remember, this notation right here is just asking you to take the derivative of what we have. Now, we can also use this when we have to do implicit differentiation. So we can use e to the x, and we can find a derivative with x's and y's in it. So let's see how we would use e to the x with implicit differentiation. So the first rule of implicit differentiation is to differentiate everything with respects to x. So let's start here. Y squared. Now remember, we're differentiating it with respects to x. So it's going to be 2y times dy with respects to x. Okay? Or if you want, you can do 2y times y prime. Either one is acceptable. Okay? Now, take a look right here. E to the y. There's something you need to recognize if you're talking about e to the y. This is now a chain rule function. Okay? So your outside function is e to the x. Your inside function is y. Okay? So take the derivative of each. This is e to the x, and the derivative of y is dy over dx, or you can say y prime. Either one is fine. So let's use the chain rule to fill this in. So we're going to fill this in. So this is going to be plus e to the y times dy dx, or e to the y times y prime. Okay? Now, let's move to the next part. Again, we can take the derivative of all the pieces. Now, this is with respects to x, so this is just going to be 4x to the first power. Okay? And remember, it's going to be dx over dx, but that's 1, so we don't have to worry about it. So this is just going to be 4x to the first power. So, how do you now find y prime? So, you have to get all the y primes on one side. So right now, what's nice is we already have it. Here's all of my y primes. So if I have y prime on the same side, I just factor out my y prime. So I'm going to get 2y plus e to the y equals 4x. And now isolate the y prime. So basically divide by 4, or 2y plus e to the y. So divide both sides by 2y plus e to the y. And then this is now your derivative. So y prime equals 4x over 2y plus e to the y. And remember, in this thing, the x stands for the x-coordinate of a point, and the y stands for the y-coordinate of a point. So we can find the derivative at any part on this graph. Okay? So this is how we use e to the x. So now, let's move on to the